Hi, I'm from the Customer Success Engineering team. In this series of short videos, we're taking a look at the baseline recommendations for configuring Zscaler Digital Experience, or ZDX. This is part 3, which covers configuring alerts. ZDX allows you to configure 3 types of alerts, each of which monitors specific metrics. Let's take a look at the recommended configuration for all 3 types. The first of these is application alerts. These are used to monitor application availability and experience. Application alerts are associated with a single configured application and web probe. For these, we recommend starting with the following settings to detect application slowness and experience issues. First, logic should be set to any so that the alert triggers if any of the criteria is matched. Then, the recommended criteria to configure are DNS time, superior or equal to 250 milliseconds, web request availability, inferior or equal to 80%, ZDX score, inferior to 15, ZDX score drop with a sensitivity of low, which will monitor for large drops in the ZDX score for the application, page fetch time, and finally, server response time. The page fetch time and the server response time criteria should check for values that are superior to the expected value for the application. This means that to configure an application alert, you'll need to have an understanding of the average value for these 2 criteria across the users whose application experience is monitored. If you don't, the risk is that the alert either won't trigger if the value is set too high, or will trigger too often and generate noise if it's set too low. Note that these criteria are a recommended starting point. An important part of configuring alerts is tuning them to make sure that they're valuable, which is something we'll talk about in a little bit. The second alert type is network alerts, which are associated to a single configured application and cloud path probe. These monitor performance along the network path to the application. This slide shows a good starting configuration for network alerts. Again, we recommend setting the logic to any for the same reason as application alerts. Then, you'll want to start with the following criteria to detect network slowness and experience issues. Latency, superior or equal to 160 milliseconds. Packet loss, superior or equal to 80%. ZDX score drop with a sensitivity of low, and ZDX score inferior to 15. And much like application alerts, you'll want to add network-specific criteria, in this case, packet count and number of hops, which should have values set based on the network. Again, these recommendations are for a good starting point, and these alerts will need to be fine-tuned once they are in place. The final alert type is device alerts. These aren't associated with applications or web or cloud path probes as they measure device performance. Here, it's recommended that you set up a global alert across all devices that checks for CPU usage superior or equal to 90%, or disk usage superior or equal to 95%. The logic here should also be any. This is an easy way to find devices across your organization that are suffering from poor performance, as well as to get early warning if abnormal CPU or disk usage patterns start showing up. An important way to ensure alerts aren't too noisy is to configure throttling so that alerts only trigger if their criteria are repeatedly met over a short period of time. This reduces unnecessary noise and prevents alert fatigue, preventing your teams from being overloaded with alerts during transient issues or short-lived spikes in activity. Here, a good baseline configuration is to set alerts to only trigger if events are repeated at least 2 or 3 times in a row, where the number of active devices is at least equal to the smallest location you have to ensure that a significant enough volume of users are online, and with a minimum devices impacted of 33%. The in-group value here should match whichever population you want the alert to monitor. When configuring alerts, it's highly recommended that you also define and apply alert labels. These provide crucial context and information that helps in the effective management and prioritization of alerts. For example, categorizing alerts based on the type of issue or the affected system components or ownership or responsibility for specific alerts. This is helpful as it will allow you to easily filter and search for specific alerts, as well as tracking trends and patterns associated with alerts that have specific labels. Labels can also be used to trigger automated responses and workflows. Finally, it's worth noting that alerts can be muted if necessary. This will prevent the alert rule from triggering while the muted toggle is active. This is a strategic tool meant to tailor alerts to your current operational context and ensure that your teams don't get flooded with unnecessary or non-urgent alerts during, for example, known temporary issues, scheduled maintenance or system upgrades, training sessions or testing phases, or for non-critical events that don't require an immediate response. Alert rules are key to getting value out of digital experience monitoring solutions, since they're what allows you to be proactively notified of issues as they develop before users are raising support tickets. If you have the ZDX Advanced license, ZDX is able to integrate with many of the industry standard ITSM tools, such as ServiceNow, Slack, PagerDuty, or Teams, to automatically create support tickets and notify support agents when specific alerts are triggered. This means you don't need to manually raise tickets in your ITSM tool when ZDX detects an issue. This is done automatically via webhooks. It's strongly recommended that you leverage these integrations to operationalize ZDX and make it a full part of your incident resolution workflows, including building processes to address and mitigate tickets raised from ZDX alerts. One detail that's important to know here is that ZDX alerts are near real time. This means that there can be up to 30 minutes between when an alert rule triggers and when notification is sent via either email or your configured integrations. Keep this in mind when building your workflows. Finally, it's important to understand that alert rules that are configured to be too sensitive will trigger too frequently to be useful, whereas alerts that are not configured to be sensitive enough will not trigger when needed. Configuring useful alerts by getting the right balance between alert noisiness and sensitivity is the most important part of building useful alerts. As such, new alert rules will almost always require a period of constant tuning and tweaking over a soak period, during which their values are adjusted until the alerts are neither so noisy that they drown out meaningful issues and create alert fatigue, or so insensitive that they don't trigger during incidents. Zscaler recommends a minimum of a 2-week soak period after ZDX is rolled out to all users. One last thing. For ZDX Advanced Organizations, an additional tool you have to manage alert frequency and avoid alert fatigue is to configure alerts as dynamic alerts. This is possible for application and network alerts that use the ZDX score or ZDX score drop criteria, and works by leveraging historical ZDX score trend data to calculate an accurate baseline ZDX score value for the application. ZDX score drops are then evaluated based on this baseline and your chosen sensitivity to determine whether the alert should trigger or not. That's it for this video. Thank you for watching.